So this is the Tsiolkovsky equation. This tells us the velocity of a rocket propulsion concept. It tells us rocket propulsion concept. So what this equation says, if we take a rocket is having some mass m and its velocity is v. We know second law of Newton is dp by dt. So where p is the momentum, rate of change of momentum is a force applied. When this rocket is ejecting gases with velocity of ejection is ve, and the mass rate of gases will be dm by dt. Here the velocity of ejection will be constant, mass will be changing with respect to the time, so this experiences downside force, and the same equal and opposite force will be acting on the rocket upside, that is called upthrust. So how much upthrust it will be experiencing is same as a ejection velocity force. So from here p is a momentum, so d by dt of p is a mass into velocity we need to write. Here mass is changing with respect to the time, not the velocity. This is the velocity of ejection, and the force F is equals to VE dm by dt. This is a force acting on the rocket or the force due to the ejection of gases. At any instant of time, after some time, it loses some mass and its velocity will be increases. After some time, suppose let us take t seconds later, this will be lighter and the velocity will be increases. So this will be initial velocity. After some time, how much velocity will it gain? That will be explained by Tsiolkovsky equation. So that will derive now. As we know, there is no external force. That's why external force is 0. But force is d by dt of momentum. If this is 0, this must be constant. So what is conserved here? Momentum is conserved. So initial momentum is equals to final momentum in this case. So let us assume a rocket of mass capital M. Its velocity at that point is v. This is initial. After some time, the rocket will be releasing some part of ejection of gases outside. Let us assume this mass is dm. What is ejecting? That value is dm. Velocity of ejection will be VE. VE is a gas ejection velocity. But this is with respect to the ground. With respect to the rocket, we need to write. So rocket will gain some velocity and loses some mass. So mass of the rocket will be m minus dm because it is releasing this dm. And velocity initially it was this, that will be increases to dv, some more value will be added up. So this is a new dv, and here relative velocity will be v minus ve because we are writing with respect to the rocket. Now applying conservation of momentum, initial momentum is equals to final momentum. Initial momentum is m into v, and final momentum will be this product and this product, m minus dm and v plus dv plus dm into v minus ve. This is relative velocity with respect to the rocket. So multiply this mv plus mdv minus dmv minus dmdv plus dmv minus dmve. This is mv. We can cancel these two, and here dmv minus dmv, these also gets cancels. This is very lighter value, so you can neglect it. So you can neglect it. The remaining is 0 is equals to mdv minus dmve. So take it left hand side, dmve is equals to mdv. Take m this side, 1 by m dm VE. I am writing, rearranging the terms, that is equals to dV. Now integrate both the sides. Integrate both sides. If you integrate both the sides, VE will be outside. 1 by m dm is equals to dV. So initial velocity is, let us assume 0, final velocity will be v, initial mass is mi, final mass is mf. So 1 by m integration will be natural log of m from initial and final, that is ve is equals to, this derivation integration of dv is a v, that is 0 to v. So ve log a minus log b, you have to write log m final minus log m initial, that is v minus 0. ve log m final by m initial base e is equals to v. But the mass is decreasing at this rate, so that's why we have to take negative sign, because m decreases. So take this formula as minus ve log base e mf by mi. So this minus, if you take it inside, the final velocity will be ve log m initial by m final. This is a velocity at particular time. So let us take one question on this one. So I have taken a rocket. Rocket is of 1000 kg and the gases are ejecting with a velocity of 2 meter per second velocity, and the rate of mass it is ejecting out is let us take 2 kg per second. So let us assume after some time this 1000 has becoming to 10 kg, because as it is ejecting up, as it is rising up, this mass will be decreases. So after it reaches to 10 kg, what will the velocity at this point? If you want to calculate, use this formula. V at this point where the mass becomes 10 times 1 by 100th time, that is 10 kg. VE value is a 2 log, initial is 1000, final is 10 base E. This will be 2 log base E 100, that is 2 log base E 10 square, that is 2 into 2 log base E 10. We know log base E 10 is 2.303 log base 10 10. So this value is 1. The answer is 2.303 here. Substitute that here. 2 into 2 is a 4 into 2.303, that is 9.212. This is the velocity of the rocket. When the mass of 1000 kg rocket becomes 10 kg, the velocity initially it was 2. After some time this will becomes more velocity. At this point you will get 9. So like this. And suppose you want to calculate the thrust, just multiply these two, because F is equals to VE dm by dt, that is 2 into 2. So experiences 4 newtons at the initial time. After some time thrust also will be decreases, because the most of the mass will be gone down. So this is a best example to calculate the velocity at any point of a rocket. That's it. Thank you.